All right, so physics. We'll start off by looking at a definition. Now, this PowerPoint is extremely detailed. I'll just be like highlighting certain things, so don't think, oh, I've got to copy down every single thing on the screen. Okay, one, that's not taking notes. Two, we won't have time for that. Okay, so as you're preparing to go to college, you're not going to be able to hold on to every single word the professor says or every single thing they put on the screen. So that's what learning how to take notes means. You get the most important parts, and then we move on from there. Okay. So with that in mind, definition of physics. Pretty much, that's pretty important for us to know. Okay. It's a study of the fundamental laws of nature. Okay. So that is a pretty broad definition. So that means anything from atoms, subatomic particles, all the way up to a galaxy. Okay, that comes into the purview of physics. So our goal in physics is to get a deeper understanding of our world, the world that we live in. Again, from the tiniest little subatomic particle to the entire universe. Okay. All right, so what we get from here on out is going to sort of be review, okay? Let's see if I can go back to that. Again, I'm going to underline things and highlight things. That's the key things you'll need to make sure that you get. All the other stuff is sort of fluff. And this comes from your textbook, so it should model your textbook. Come on, are you not going to let me? Ah, there we go. That's what I want. There we go. Oh, fiddlesticks. We ran into this last year. All right, so physics is one of the many natural sciences. Pretty much any science you've studied, chemistry, biology, geology, all those are considered natural sciences. And science in general is just an organized way of thinking about the world that we live in. It's a process. It's not just collecting a bunch of facts and that's it. It's a process. So that means we have the scientific method. Okay. Scientists' goal is to try to explain or find explanations for observations that they see, for knowledge that they gained about certain events. All right, so scientific method, make sure you write down these 4 steps because pretty much that's what we summarize the scientific method into, these 4 steps. Observation, inference and hypothesis, test and conclusions. Now my stool is too tall. There we go. So scientific method always starts with a question or an observation, like, well, I wonder why that happens. Okay. Then we start to make some inferences or form some hypotheses. I think this happens because. Okay. And then we come up with an experiment to test that hypothesis. And based on the results of that experiment, we come to a conclusion. Okay. I have those 4. Okay. Let's see. A couple of things to mention out of here. Of course, we start with an observation. Well, I already said that. Observations lead to inferences. So if you want to kind of write this out, here we go. Observations, that's where we always start. That leads to an inference or a hypothesis. Kind of need to know what the definitions of those words are. A lot of times on a test or quiz, they'll say infer. You need to know what that means. So an inference is a logical interpretation. A hypothesis is a detailed scientific explanation for a set of observations that can be verified by experiments or rejected by experiments. So you need to know what we're talking about when we mention those two words. When we infer something, that's where we just have a logical interpretation of something um, based on some observations that we've seen. Okay, so I can look at something and infer that. So if I can infer that all of y'all are very self-motivated people because you're sitting here in this class today. That's an observation. I'm observing you sitting here. I'm observing that you're all working. So I'm going to infer that y'all are hardworking, self-motivated people. Does that necessarily make it absolutely true that you are? Not really, because you could be, I'm only in here because mom and daddy make me come in here. Okay. And that's probably true. That was true in my case as a teenager. It's like, I don't know, parents make me come, so I have to come. But while I was in there, I was working hard. Okay. Um, Hypothesis is a detailed scientific explanation for a set of observations, but the difference is that you can verify or reject it by experimentation. So you have to be able to do an experiment to try and prove your hypothesis correct or to have it proven incorrect, okay, or rejected. All right, so let's go on. I wouldn't write any of this down just yet. So experiment that disagrees with your hypothesis, that we say that is rejects the hypothesis. So we have to come along, we have to make some tweaks to our hypothesis. Yeah, we'll skip through that. Those are just examples. Another definition that we need to make sure we know is theory. Scientific theory is a detailed explanation of some aspects of nature that account for a set of well-tested hypotheses. So after we have our hypotheses and we have done experiments on it and our experiments have verified that hypothesis over and over and over again, then we can say that that is a scientific theory. Okay? So theories are well supported explanations. So we have to have lots and lots of experimentation that backs up our hypothesis before it becomes a scientific theory. So the key word there is well supported. An example. Now, this was a little confusing to me at first, so I actually had to do a little research about it. Because the example they give in the book is about gravity. Well, I always thought of gravity more as a law. Like, it's not going to change, okay? But there are two aspects of gravity that they're looking at. One aspect of gravity holds as a scientific theory, whereas the other aspect of gravity holds as a law. And we'll get into that in just a second. So an example, and I would write this down so that, because like I said, it was confusing to me too. An example is the theory of gravity, which explains why an object falls with constant acceleration to the surface of the earth. Okay, so usually when we think of the law of gravity, we think of gravity being, well, if I drop something, it's going to fall because of gravity. That's the law of gravitation, that it will be attracted to the earth and it will fall to the earth. The theory that they're talking about here is why? Why does it fall to the earth? Why doesn't it just float away, or just stay right where it's at? Okay. So an explanation of why that happens or doesn't happen is considered a theory. Okay. We have lots of experimentation that's been done on that and that supports our hypotheses for it. But we can't cross over and call it a law. Okay. That aspect of it anyway. Now, so that's a scientific theory. Law, on the other hand, laws of nature are well-supported descriptions of nature. So we have something like the law of the conservation of energy. We call that a law, or the 3 laws of thermodynamics. We call those laws because they describe what's happening. They don't tell us why. Law of conservation of energy says energy cannot be created or destroyed, period. Boom. Doesn't tell us why. Okay. The law of gravitation tells us that if I drop this, it will fall to the earth, period. Doesn't really tell me why. Okay. So there's your difference in those 2 definitions, and sometimes that can get a little hairy. So theories try to explain why or how something happens. Laws describe something that's happening. Okay, so there's your biggest differences between those 2 things. Okay. So if you do an experiment and your experiment agrees with your hypothesis, then we can say that you are validating that scientific theory. Okay. But if your experiment does not agree, then we have to reject or discard that as a theory and tweak it, change it, and retest it again. Does that make sense? Okay, now, where's my little... I ought to be able to move this around, right? I can. Yay. Maybe that'll work. All right. So laws do not provide explanations. We already talked about that. If a new observation agrees with the theory, then we can say disagrees, then the theory has to be disregarded and we have to start over. We already talked